Welcome, pre-algebra. We are in lesson 50. We're going to talk about scientific notation for numbers greater than 10. So when we multiply this number, 0.0534 times 1,000, we get 53.4, because what happens is we move the decimal place the number of zeros that we have. So we have 1, 2, 3 zeros. That would mean 1, 2, 3. That would be where the decimal place goes. So 53.4. And we can do that pretty easily in our head, right? We just move that decimal. And because of this, we can write 10 to the third. Because 10 to the third, that's just the number of zeros that we have. We know that 10 times 10 times 10 is equal to 1,000, right? So that means that we could write this as 0.0534 times 10 to the third, and it would still equal 53.4. Let's still get the same answer. When we multiply a number by a positive power of 10, we move the decimal point to the right, the number of places indicated by the exponent. So if this is a positive exponent, then we move the decimal to the positive side of the number line. Here's the number line, right? And we know that this is the origin, this is the positive side, and this is the negative side. So when we multiply times a positive exponent, that's the number of places that we move the decimal. So it's really easy to look at this and say, oh, we're just moving it 3 times. So 1, 2, 3 would be 53.4, which is the answer here. So it's very visual. Scientific notation is a very visual math. It doesn't require a whole lot of thought in what that number actually is. And when we know, likewise, because of that, if I had 53, or if I had 5.34 times 10 to the negative 1, let's say to the negative 2, the negative means I would move that decimal place to the negative side of the number line 2 places. So I would go 1, 2, and that's where my decimal would be. I have to put a 0 here, I'd put the decimal, and then I'd put a 0. And so that number would equal 0.0534 because of where I needed to move it to. So you can see how the negative exponent and the positive exponent impact a number, and how we can just very visually do the multiplication without having to whip out a calculator. That's what makes scientific notation so easy and so powerful. So let's look at some practice problems for that. Here we have 50.1, and we are going to write 7,024,000 in scientific notation. So we always want to have just a ones place when we do scientific notation. So that means we're going to have 7.024, and there are no more numbers, times 10 to some exponent. So we have to figure out what the exponent is. So 1, 2, 3, 4, 5, 6, right? So it's going to be a positive 6, because when we multiply, we'll move this decimal place back to the right side, because it's positive, right? The way I like to remember it is like this. Let me erase this. Whenever you're counting which direction, or whether it's positive or negative, you're going to write the exponent in the opposite direction of the number line. So when we multiply, the positive means we go in the direction of the number line, but when we're figuring it out, we have to do the opposite. So if I move my decimal to the left to right scientific notation, it's going to be a positive. If I have to move my decimal to the right, then it's going to be a negative exponent on my 10. All right, those are things that you need to remember. This is when writing the scientific notation. All right, but when multiplying, a positive exponent means you move it to the right. This is to multiply. When we multiply this number, a positive exponent goes to the right and a negative exponent goes to the left. So it's just the opposite. When we multiply, it follows the number line. When we turn it into scientific notation, it's the opposite of the number line. So those are things that you have to kind of understand why that works. So this would be the way we would write 7,024,000 in scientific notation. Let's do 50.2. All right, so 50.2 says that we're going to write 476.23 in scientific notation, so in SN. So we are just going to put our decimal point here, 4.7623, and we know that's times 10 to the something, right? So now let's count and see what we actually moved our decimal point. 1, 2, we moved it to the left, so that means it's going to be a positive 2, right? A positive 2, because we moved it the opposite of the number line. When we multiply, it follows the number line, but when we move the decimal point to write our scientific notation, it is the opposite of the number line. So moving to the left means it's a positive exponent. So let's look at scientific notation for numbers between 0 and 1. And that's where our negatives come into play. So in 50.3, we are asked to write 0.0652 in scientific notation. So that's in scientific notation. So what we want to have is a ones place. We only ever want to have a ones place. So that would be 6.52 times 10 to the something, right? So let's figure out what that something is. So I'm going 1, 2 places, and because I'm going to the right, the opposite of the right side would be negative. So that'd be negative 2. And the reason that is because when we multiply, we want this number to get smaller. And in order to make it smaller, we need a negative exponent. All right, we understand what negative exponents do. Negative exponents, they actually divide. So we're dividing this number. All right, so let's look at 50.4, see how that works. So we have 2 numbers here, and we are going to write these numbers in standard notation. So first we have 4.6 times 10 to the negative 4. And then we have 4.6 times 10 to the positive 4. Okay? So the way we would write this is when it's negative, it moves to the negative side of the number line when we multiply. So this would be, let me write this here, 4 and 6. I know it's negative, so I'm going to go this way, so I need some zeros. And I'll figure out where the decimal goes later. So right now it's here. So, but I want to move it 1, 2, 3, 4 places. So my number is actually going to be 0.00046. That is going to be the value of 4.6 times 10 to the negative 4. But here I have a positive 4. So I'm going to move my decimal place to the right, because on the number line, to the right is positive, to the left is negative. So when I multiply, I follow the rules of the number line. So I would have 4, 6, and I'm going to need some zeros. I'm going to need a few zeros. So I'm just going to put a few out here. And I'm going to start with my decimal point where it is, and I'm going to make 4 hops or 4 moves. So 1, 2, 3, 4. That's where I put my decimal place. So I can drop any zeros behind the decimal place. So the answer here would be 46,000 because I have 3 zeros before the decimal place. So whenever you are multiplying scientific notation to see what the number actually is, follow the rules of the number line. If it's to the right, if it's a positive exponent, it's to the right. If it is a negative exponent, we move that decimal place to the left. Okay? That's what we have to remember. And when we create that scientific notation, we work off of the opposite. And the reason we do that is so that when we multiply, it does follow the rules of the number line, which makes it easier to remember. All right, that's all we have for lesson 50. If you have any more questions about scientific notation, I know that it can be kind of wonky. You know, it's you have to wrap your head around it, and you have to be able to think about it. So give yourself permission to rewatch the video and see what you need to do. And if you still can't figure it out, if you still can't figure it out, just message and ask me. And I'll see you in lesson 50.